Hello and welcome back. This is Intermediate Coding in Minecraft. I'm your favorite computer science teacher, Mr. Pitts, and we just wrapped up the Lesson 5 Challenge Assessment, which means we're headed in through this newly unlocked door to Lesson 6, Advanced Loops. That's right, you guessed it. Lesson 6 is all about advanced loops. So let's talk to this NPC and see what we've got. So there are two other loops we will look at: the forever loop and the on start loop. Not sure why forever got the bold there and on start did not, but forever and on start are the two new loops. We will also look at the pause command, which can be useful in any loop. It can be useful, not in all situations, but it is extremely useful where needed. The forever loop can be used to run blocks of code continuously forever. And the on-start loop allows us to run some blocks when the game starts. So the things you want to have happen right off the bat. Can you think of a time when you wanted to repeat something forever or something every few seconds or minutes? If you have an idea, throw that in the comments. I'm thinking breathing. I'd like to continue living, and breathing is one of the things that we must do for that. So every few seconds I like to breathe. It doesn't have to be on a timer though, so maybe a heartbeat would be a better example there. But let's see what we have under the Learn More tab. What about breathing or heart beating? This is something which repeats forever. How about the clock ticking, especially in video games? You know, a lot of levels will have maybe a timer that you have to complete the game in, and so it's nice to have a clock that ticks down every second. And so we would need some of these forever loops and pause commands to be able to make that happen in code. And then lastly, when the game starts, you may want to do some setup, such as spawn some mobs or change the game mode or initialize your variables. Loops are still found in the loops drawer in MakeCode. They make it real easy for us to find them. Forever loops, this will sit on its own, so it's not going to be inside of a chat command or any other kind of event command. It just sits out there and will start running as soon as the code begins. The blocks inside of the loop will run one after another in order and then start over again. It's a very useful loop when you want something to happen over and over again automatically. On start, this is not a picture of the on start. However, the on start loop has been just kind of hanging out. Every time we open the code builder, there usually is an on start there. And so far in the course, we have just thrown it away like a garnish next to a steak or something, just sort of get rid of that on start. Today, we're actually going to use it. Today is the day that we use the on start loop. And it's very exciting for the on start loop finally gets to be used. Pause command is a block which is commonly used in loops. Some languages call it a wait. Others call it a pause. This is in milliseconds. That's the ms next to pause. There are 1,000 milliseconds in every 1 second. So again, milli is the prefix for thousand. So think about millennia or millimeter. There are 1,000 millimeters in 1 meter. So that's how you remember 1,000 milliseconds is in 1 second. So if you were wanting the pause to happen for 1/2 of a second, you would put 500 milliseconds. If you wanted it to be 1/4 of a second, you would put 250 milliseconds. And then 1/10 of a second, which is the minimum that the game here will recognize, is 100 milliseconds. This pause block, by the way, will go up to 5,000 milliseconds, which is 5 seconds. So anywhere from 1/10 of a second to 5 seconds is how long we could make our pause in Microsoft MakeCode. Now we're going to move on into the next NPC, and this fella should set us up for activity 1. So forever loops, again, continuously run a series of blocks from the start until the program ends or we end it. Pause command, again, we're going to pause the code for a number of milliseconds. Fantastic. So we're going to do activity 1 and 2 here in this little area. In activity 1, we will use the forever blocks and the pause block to add some functionality to the game. We will create a program which will change any blocks under us to brick blocks to form a path where we will walk. We will then extend our program to make our agent. This is not an extension. We just do one activity, then the next. They're completely unrelated, but that's okay. Okay, so loops drawer, we're going to drag out a forever block. Easy enough. Then we're going to go to the blocks drawer, drag a place. And then it says change the type of brick to the type of block to brick block. And then it says change the y coordinate to -1. Now remember, the left coordinate's your x, the middle coordinate is y, and the left coordinate is z, with x being east and west, z being north and south, and y being up and down. So when we change that up and down coordinate to -1, that's going to represent the block under our feet. Remember that these little symbols in the position mean that it's relative to the player. So that means 0 blocks in the x direction, 0 blocks in the z direction, and -1 block in the y direction. This is very short and sweet code, but we're going to see the power of the forever loop here in just a second. So this is your screenshot for activity 1. Let's test that out. Now whenever I change, so see, whenever I walk, there is going to change the block that I'm on to a brick block, and this will happen forever, right? Because it's running in a forever loop. So I could sit here for 10 minutes and come back and move around, and it would change the block underneath me to brick. Now the issue with this is it's going to run forever. So like if I went on and left the area here, look, it's still going to make brick blocks everywhere I go. Also, if I jump up in the air, it'll make brick blocks under me, you know. So sometimes, so, you know, you have to be real careful with this one, because you can get somewhere weird and change the whole world to bricks. So as we see, it's changing that -1 to brick block, and it'll keep going until we stop it. So remember, to stop code, you press C, and then just don't run it, right? We hit X to exit out. Again, this is your screenshot for activity 1, and that's how a forever block works. It starts as soon as you start the code and runs until you stop the code. Beautiful thing. All right, so now we want to reset our area. Oops. And then go into activity 2. And in this activity, we will use a forever loop to make the agent dance around. Exciting stuff. So we're going to add a forever loop block. Remember, that's in the loops drawer. Easy enough. And then it says you decide how to move the agent. So employ some of your creativity here. Use a series of move and turn blocks to move your agent about. Combine these with loops to perform the same action multiple times. You will also place the pause button or pause code at points within your series of blocks to get your agent to stop. And we'll see why in just a second. You can set the values of the pause blocks to anything from 100 to 5,000 milliseconds. That's a range of 1/10 of a second all the way up to 5 seconds. So how do we do that? So let's start with a, start with an agent move. Let's make him go right. Then make him go left by 2. So basically what I want him to do is go back and forth over a 3-block range. So if he goes right 1 and then left by 2 and then, let's see, and then right by 2, and then, whoops, and then left by 1. Let's see if that is sort of what we're thinking. And I want to get a pause at the end just so we can see how that works. So we'll pause him for, let's make it a second. So it's 1,000 milliseconds. All right, so again, remember, the forever loop is going to run as soon as I press the play button. So as soon as we run the code, this thing's going to start going, and it's going to go forever until we stop it. So again, he's sort of wiggling back and forth across this 3-block expanse. And he'll do that forever until I pause him. Let's see. We can also throw a repeat in here and maybe some turns. So 4 times would turn him all the way around once. And then we can turn him all the way around the other direction, and then he can do his little shimmy back and forth. So let's put a pause in between here and here, and then maybe cut that down to half a second instead of a full second. See how that looks. Oh, and then we'll add a little jump at the end. How about that? We go up 1, and then he'll go down 1. And then put another pause. Okay. So something like that. You can make this as long as you want, or as short as you want. But it's kind of fun just to sort of play around with and see how the forever loop and how the pause works. So as soon as I press play, he'll go at it. Here's his little spin and his jump. There we go. Back and forth, spin, and the jump. And yep, he will do this in perpetuity, which means forever and ever and ever. I could go get lunch, snacks, come back, and he would still be doing this. So fun dance. Again, whatever you decide to do here for, to show off your creative side, take a screenshot of that, and that will be your submission for activity 2. Once you've done activity 1 and 2, we hit completed and move on through the newly unlocked door to the next NPC. So finally, it's here. We're going to use the onStart block. We've been looking at it for weeks, and now we're going to actually use it. It's a special event. It runs before anything else when the program starts. You can use it to set up variables and other things that you may want to initialize before anything else happens. Remember all the way back to the beginning of the course, I said that every variable in Microsoft MakeCode gets defaulted to 0. So if you don't set the value of a variable to something, headed into activity 3, it will be 0. It is not like that in many coding languages. In many coding languages, you have to initialize a variable when you declare it, when you create it. And then other languages, if you don't initialize it and it doesn't have a value and you try to run the code, it's going to crash. So the setup for these variables at the very beginning of the code is key, absolutely key. And that's why the onStart block exists. And again, for other purposes, we may want to spawn monsters or mobs or whatever, at the beginning of the code. So we're going to add some functionality with the onStart. We're going to use blocks of code, which will spawn a random number of chickens in the play area surrounding us when the program starts. Yes, it is. The onStart block is usually already placed for you, and we've thrown it away until now. But if we need one, we can drag it out from the loops. Now, one of the things to note is that you can only run one onStart. If you try to do another onStart, it's going to be grayed out like this. So one onStart per code. Next up, we're going to create a variable. This is old lesson 2 stuff. Make a variable, and they want us to name it no. Whoops. They want us to name it no of chickens to represent number of chickens, which you could just make it number of chickens. But anyway, no of chickens means number of chickens. And you'll use this variable to set the number of chickens to spawn when the program starts. So we're going to go to the variables drawer and use a set and put it inside of the onStart. This is how you set the value of a variable, and it could be any variable. So if we created 4 variables, they would all be on the list here. And we would set that to whatever we want that to be. Now for the purposes of this activity, we're going to go to the math drawer, grab a random block, and put that in there. So what's going to happen with random is it will choose a random number between this number and this number. So 0 is a possibility, all the way up to 10 is a possibility, whole numbers. It wouldn't be very fun code if we got 0 chickens, so we're going to change the lower bound here to 1. All right, next we're going to use say to put some fun things in the chat. Go back and use our text join so that we can put a piece of text with the variable itself. And so what we're going to say is, we're going to put number of chickens with a colon and a space. That way there's a nice space in between the words and the variable. And then the variable itself will go here. So in the say, we will get number of chickens, and then it will show whatever number the random number generator selected for us. Okay, next we're going to do a repeat loop. And then we're going to take number of chickens and make that the number of times that we repeat the loop. So this means this loop will be repeated the random number, somewhere between 1 and 10. We won't know until we run the code. All right, mobs, we're going to spawn an animal. It's default to chicken, but you want to make sure, right? And then if you recall our conversation about position variables in Minecraft, this is relative to the player. So relative 0, relative 0, relative 0 means the block that you're currently standing on. What we're going to do is change that to a random position in the range from the block we're standing on to the block we're standing on. Okay, this is where I see a lot of errors in class with students is they give us the coordinates here, 88, 83, 163, and 92, 83, 167. And a lot of students will sort of speed run through this, and they'll come in here and they'll type in 88, 83, 163, and then 92, 83, and 167, thinking that they're doing and following the directions. Problem is, if you don't change this from relative position to the world, what you're actually telling it is to spawn a chicken 88 blocks away to 92 blocks away in the X direction, and 163 to 167 blocks away in the Y direction. So close to 300 blocks away, and 83 blocks in the air, which is okay because they do sort of float down if you spawn them in the air. And so they spawn they spawn the chickens, and they think the code isn't working, but it is. They're just being spawned hundreds of blocks away, so we can't see them. So we messed up here. So what we have to do first is grab this world block and put that in over the relative block. And then now we can put in our actual coordinates, which will represent basically the area that we're doing the activity in, the little wrestling ring, if you will. And you make sure you put these in 100% correct, or else they will spawn in weird places. So we don't want 8 chickens to appear all at once. Not sure why, but they want us to show how to use the pause block here. So what we're going to do is we're going to put the pause inside of the repeat, and they want us to change it to 1,000 seconds, 1,000 milliseconds, which is 1 second. So it will, once we hit on start, once we play, we'll set number of chickens to a random number. Let's call it 3. Okay. Then it'll say number of chickens 3. And then we will repeat 3 times where we spawn a chicken in the area and wait a second. Come back up to the top of the repeat, spawn a chicken, wait a second. Spawn a chicken, wait a second, exit, exit. We're done. That's what we expect. All right. Tried a couple different times to see what we get. Number of chickens 6. And here they come. 1, 2, 3, 4, 5, and 6. And we're done. All right, let's try it one more time. Again, you can't rerun it because it only happens on start. So that's the thing about the on start, is it goes through one time. Number of chickens 7 this time, so we get 1, 2, 3. And 7. Okay, fantastic. So there's your code for activity 3. Screenshot that, throw that in your assignment, and now we know how to use the on start. So we're going to complete that and then move on to the next NPC. It says activity 3, but this is actually our activity 4. So we're going to learn a little bit about modularity. This is a big one, so you want to do the best you can to wrap your head around this. Modularity is a key concept in coding. So in previous lessons, we used loops to repeat actions multiple times, such as coding the agent to build a fenced pen. This allowed us to run the same code multiple times rather than having multiple lines of code performing the same action. Yes, where are you going with that? Okay, let's keep it going. So modularity allows us to reuse the same code and presents us a way to reduce the amount of code that we have to repeat. So we'll see an example here in just a moment. But basically the way modularity works is in a big piece of code, you don't want to have to write the same lines of code multiple times. What we want to do is we want to get what's called a function working, and then whenever we need to run that code, we just call that function to run again. So that way we write the code one time, we make sure that it works, and then we call that function whenever we need that code to run. This also helps with something called debugging. So when a code has an error in it, when it doesn't do what it's supposed to do, or in a different language, if it doesn't run, then having to find out where the error is can be troublesome. If your code is broken up into small pieces, small functions, and we know function A works, function B works, and then function C doesn't work for some reason, then that's where the problem lies. And so it makes it easier to fix your code as well. So modularity is the process of splitting the code into smaller, reusable pieces. Okay, so we're going to hop into activity 4. So in this activity, we will use a function for the first time. It's a beautiful thing. Almost wish we'd gotten this at the beginning of coding. I understand why we didn't, but this is going to help you out for your next course. But in the activity, we will use a function block to make our code reusable and easy to maintain. So in this one, we're going to create a function which will build one level of a structure, a simple house. We've seen this before extremely recently, and be called multiple times to repeat this process to build upwards. Okay. So we're going to build a hollow structure like in the picture, just like the lesson 5 assessment. Could have used this a few days ago, right? When we could use the below code to have the agent build a series of blocks to make one wall, turn and create another wall, and then when the 4 walls are complete, move up and repeat the process. So this code is already preloaded in. What they want us to do is run this code, see what we get, and then we will actually use functions to make the same code and then compare that build as well. So it says here they want us to run this code, put build in the chat command, and make sure that we have some inventory for the agent. So let's do that first. Okay, so in this code, the agent goes up and places down and then goes forward, places down and goes forward, and then goes all the way around and then goes up again. Okay, so we get a hollow box again, no top, no bottom, with 1, 2, 3, 4, 5 blocks and 3 tall. Okay, 5 by 5 by 3 is what we're getting. All right, so let's reset the area and then head back into the activity. So how are we going to do this and break this into functions? Let me caution you, when using functions, you have to set them up just right whenever you're creating the function. So you want to make sure that you know exactly how to set up your function, what type of arguments are getting passed to it, what type of variables are being used in it before you finish that setup, because there's no way to go back in and edit it. And then you're kind of stuck. And I have seen the program sort of mess up if the functions are not created properly. So do not create a function quickly. Double check it and make sure that it's right. So that means we want to read all the way through and then go in to make a function. So let's do that. What if we wanted to be able to reuse this code to create structures with different wall lengths or heights? At the minute, we would need to change the code, the number of variable, and we would actually have to go in and change this number is what they're saying. So we're going to go into the code and break it into multiple functions to enable them to be reused and called from multiple places. You click on the functions button to make a function. We're going to replace the default function name of do something with build wall. Please don't leave it do something. You won't know what it does. Just like with a variable, make it something specific. So build wall is going to build a wall, right? And then we're going to click on the number option to add a number parameter. This parameter will be used to set the length of the wall and then change the parameter name to length. So again, name is build wall, one parameter, which is the number parameter. All right, so let's try that out. So functions, we go to make a function, we change do something to build wall, and we have to click on the number here, and then we're going to change that to length. If you accidentally click on any other thing other than number, you won't be able to complete it because you won't be able to put a number here, right? So if you click text by accident, it won't work. So build wall with length here. If you mess up, you can always delete it and then add another one. But once we click done, that's it. So we want to make sure the function is exactly the way we want it before we click done. And that creates this thing. And it has a little hump here because it's not going to connect to any other code. Okay, so this is the process to build a wall. So what we're going to do is we're going to add a repeat 4 times. And set the loop control variable, which is this 4, to be length. Now the way we use these variables inside of the function is we just click and drag it out. And assuming we made this a number, it will fit into any number slot. And one of the mistakes that I see happen in class a lot are students trying to follow along and they see the word length there, and so they think they need to go and create a variable named length and put that there in that spot. And that is not correct, because you can create a variable named length and it be separate from the length that occurs in that function. That's the parameter that's passed to that function. So the only way to use that properly is to grab that length or that variable, that parameter from the function and drag it down to be used inside of the function. We cannot create another variable of the same name and have it work properly. Okay, so now we're going to do agent place down. And we're going to do agent move forward by 1. So basically what this is going to do is, once this function is called, it's going to run length times and it's going to place down and move forward. Place down, move forward, place down, move forward, place down, move forward. So if we call build wall 4, we will get a wall with 4 blocks. So now that we have built a single wall, we're going to create a function that uses that function to create a single level of the building. So we're going to create build floor with no parameters. So go to functions, make a new function, and change the name to build floor. Extremely important to name these something specific so that we know what they're doing. No parameters for this one. Okay. In the build floor, we're going to add a repeat. Go back to the functions drawer, and what we're going to use is call build wall and place it inside of this loop. And then we're going to change this to a 4. And then after the build wall, we're going to place an agent turn right. So what this is doing, when we run build floor, we're going to repeat 4 times. It's going to first call build wall, which basically means we're going to exit here and we're going to come over here and run build wall. And remember, build wall 4 is going to give us a wall with 4 blocks. Then he's going to turn right. And then we're going to come back up to the repeat. And we're going to call build wall again, which is going to give us 4 blocks. And then we're going to turn right, come back up to the top of the repeat, build wall, turn, build wall. So we should get our 4 walls, right? So build floor will give us that square shape. So we're going to create a third function called build house, and that's going to have a number parameter named height. So again, make sure you double check what you have to create. So build house and a number parameter. And that's going to be height. All right, so we're going to add a repeat and replace the loop control variable with the height parameter. Remember, to use a parameter in here, we just click it, drag it down. We're going to start with agent move up. Remember, the first thing he does is go up because we're placing down. And then we're going to do a call build floor. So we've now created 3 functions that when called correctly will be used to build the structure. So to test this out, we're going to use a chat command and change it to run. Honestly, I like to have my chat commands named test, but that's okay. We'll use run. So when I'm testing code, run is fine. And then what we want to do is put the call build house inside here and change it to 3. Because remember, this is the number that goes into height. So that's how tall we want the structures to be, 3. And then he will repeat 3 times to move up and then build a floor. So each function is calling the next function. And so each little piece of code works perfectly. And if there's an error, we can fix a little tiny piece of code instead of a big piece of code. Now for this example, it looks like more code. However, there are a lot of applications, in most applications, where the code gets too big to do this great big long piece of code. And it's nice to have it broken out into functions. So instead of having to do all of this code, 1, 2, 3 lines, it's replaced with 1 line. And technically for build floor, it's if we repeat 4 times, that's 3 times 4 is 12, 13. So this replaces 14 lines of code here. So you can make your code a lot better. You can also, check this out, save space by making them small. So once we know this works, you can minimize it and you don't have to look at it. Okay. So now we're going to test this, and the way we test it again is using run. That's going to call build house 3, which is going to 3 times call build floor, and build floor actually calls build wall 4 times. Make sure we have some more blocks. I don't think 16 is going to be enough. And we should get the same structure that we saw when we used the build command. And there we go. 1, 2, 3, 4, 5 long by 5 long by 3 tall. Same exact structure. So again, there's modularity. Breaking one piece of code into smaller pieces also helps you problem solve. Once you break your problems into small pieces, each piece is a function, and then you put the functions together to work. There's your screenshot for activity 4. Random chickens wandering around. Yes, sir. All right, head through the newly unlocked door to the challenge assessment. Now this one, this is a robust challenge assessment. Again, this NPC will give you a link to codingcredentials.com if that's where you're uploading your make code. Now we have a giant ring here, giant area to work in. Let's read the problem to help understand it. So, using make code, you can create some code which expands on the previous activity of making chickens randomly appear. So we're going to do a callback to that activity where we make the chickens appear. You'll count the number of chickens you can kill in a set period of time. Yes, they chose violence today. And show the score, the number of chickens killed at the end of the time. So we're keeping track of the number of chickens killed with a variable called score. At the start of the game, you must initialize a score variable to 0. Well, yes, you want to start a game with the score 0. And then from there, we're going to add to it each time we kill a chicken. You want to set the length in seconds of the game. You choose. I will recommend 20. 30 gets a little long. 10 might be a little short, but I recommend 20, but you choose. So you're going to set the length that you want of the game. You're going to hard code that in. After the score is displayed, then you'll kill all of the chickens automatically. Okay, there's a lot to know that's not covered here on the board. So as far as variables, remember you want one to keep score. You also want one for the length of the game. And then in order to keep track of how far into the game you are, you're going to want a variable for the current time as well. So think about that. What we used in the past, that forever loop with a 1-second pause, should allow you to keep track of the time. Let me show you a couple things in here before I let you work on it. So again, new project. No, not new here. All right, so at this point in the semester, you should be getting really comfortable with knowing where things are and what blocks to use. And even when you haven't used a block before, sort of figuring out what it is from the way that it's set up. So when it says kill all chickens, so by the way, here's a block for on animal killed. So when a chicken's killed, it's going to run this code. That's going to be helpful here. What else is going to be helpful in here is the kill. Now, one of the things you want to be careful of with the kill block is the default is nearest player. And what I saw happen in class is someone put inside a forever loop kill nearest player. So if I were to press start here, what this is going to do, who is the nearest player? Well, it's me. So if I press start here, I'm going to enter a forever loop where it's going to kill the nearest player. And so what happened to the student is they pressed start and it killed them, and then they hit respawn and then it killed them again, and then they hit respawn and it killed them again, respawn, killed them again, and we actually had to close the game to get them back to where they could be alive because it was a forever loop and it's killed. So you also want to, whenever we're going to kill all the chickens, this is what we will use, is this all animal, right? And make sure that's chicken. So now that's going to kill all the chickens whenever it's time to do that. Some hints, you will need to do some comparisons here. So you will need to use some logic right? Think about when the game is over. And then think about how to display the score. So there's a lot here. Probably take you multiple class periods to work on it. Okay, that's all the help I'll give you before you work on it. Of course, I will post the Lesson 6 Challenge Assessment Supplemental after this. So once you've gotten it done and figured it out, you can head over and check out that video there. So again, this has been Lesson 6. Good luck with the assessment. I will tell you, it's a big one, but it is a fun one. The last piece of advice that I would give you for this game, it's going to spawn chickens and then you have to kill them. It is a bit violent. I think one of the things that makes it better, and I always tell my students not to do this at the beginning of the course, but here at this point, I trust you, right? So what I usually do is I go over here to settings, and for the game mode, change it to creative. And that way I can actually come in and give myself a sword with which to slay the chickens. And again, I think one hit with a netherite sword makes it a little more humane than bludgeoning them to death with the agent device that looks like a remote. So there's a little hint there for you as well. So again, hope you enjoyed Lesson 6. Hope this was helpful. It's a big one. It's pretty much the last one in the list that we actually go through and do activities and learn. The Lesson 7 is a project where we use what we've learned. So yeah, if you can make it through this assessment, that's the last lesson that we go through with this type of thing. So good luck with the game. It can be a lot of fun. Hop over and check out my Lesson 6 assessment video whenever you've made your attempt and you've gotten it done and you want to double check that code. So thanks again for watching. This has been Intermediate Coding in Minecraft with your favorite computer science teacher, Mr. Pitts, and we'll see you in the next video. Thank you. Bye. See ya. Take care. Have a great one.